Hi, and welcome to the second video in the series of videos about the P5JS JavaScript quilting project. Today I'll go through some of the details of, first of all, some things I missed in the first video, just to fill you in. Secondly, I will talk about how you can take turtle graphics, which some of you I know produced in Python for the first part of the assignment, and convert those to JavaScript in such a way that you can use them in your quilt design. So uh, one of the things that I omitted to say was that, first of all, the only thing you have to um, actually touch and submit is um, basically a block, a quilt block. One or more quilt blocks, you're welcome to do more than one. For instance, this nine patch, which is actually an hourglass, um, uh, is something that you would have to create based on the example and then put into your quilt. And of course, you take blocks that are posted by other students and you can put those into your quilt as well. Again, keeping them as blocks, which lets you put them in whatever arrangement you want and take advantage of the framework, which is doing a lot of work for you here. So I've provide block.js, I provide p5.js, quilt.js, sketch.js, style.css, and you will have to work within inside the constraints of that template. This is a template or a framework rather similar to what you might have if you use, say, React or Vue, except this is a much simpler and graphical oriented framework rather than a general web development framework. Starting with the things you would have to change. In the index.html, when you add a block, you will need to, or blocks actually, you will need to add a line to the HTML telling the web browser the name of your JavaScript file that contains the methods and classes you're going to be using. For instance, when I put nine patch in there, I had to, when I created a nine patch and wanted to use it, let's say, I had to put this line you're looking at now, script source equals ninepath.js. And you would do that for each block that you're using. Uh, also, you would need to, in sketch.js, go through and instantiate and that is means actually create an object from a class, create your, say, nine patch using the new operator and passing the appropriate parameters. We'll talk more about those in a minute, and put those into the array of blocks that actually Quilt maintains, that is used to collect all the blocks together so you can display them all in the same quilt. So it's a pretty small change, and you're welcome to combine them any way you want. I've done a simple odd even combination with nine patch and another block called turtle sample, which I'm going to go into and talk about in more depth in just a moment, because that was the block that I converted from Python. So although is an intimidating looking amount of code, it actually isn't a lot of code for that you need to produce, because the framework is doing a lot of the work for you. Okay, in the previous video, I talked about what each of some of the files did. This time, I'm going to talk specifically about the file called sketch turtlesample.js. Sorry, turtlesample.js. This is it, and it's mentioned in the, obviously, it's mentioned in the HTML, so it will be made available. And it also extends block, like, in other words, it's a kind of block. It is a block, like all the other blocks, has some of the same methods, but in this one, there's actually an extra parameter. We'll talk about that in just a minute, which is I'm calling a turtle or a pin. This is the key to using uh, a modified form of turtle graphics inside the block. You can use all of the built-in P5JS methods like square and circle and triangle in any combination you want, and you don't need a special class to do that. You just simply need to give the name of those elements. But if you want to actually draw using TurtleGrafx commands a design inside a block, then you need to use Turtle this a block like this, which I'm calling Turtle sample, obviously because it's a sample, and you would make your own variation of this. But it has to have, in addition to the parameters that all of the blocks have, it has to take another parameter here called the turtle, which is actually a uh, reference to a pin. So let's look at this. To make TurtleGrafx work inside a block, I basically copied over um, uh, Python's implementation of TurtleGrafx, which is pretty simple, and then changed the methods, didn't need a lot of changes, to make it work inside of JavaScript rather than requiring Python. And we can actually look at that here. If we look at pin.js, you can see some familiar looking methods. Forward moves the turtle forward a specified amount, certain amount. Backward moves backward. Right, left. Set position, which jumps to another position. If the pin's up, it just jumps there. If the pin's down, it leaves a line as it moves. And some other just utility functions. Not very many, though. Um, so these are basically the same functions. Now they work the same, let's say, as they would in Python. So to make the triangles you see, the Sierpinski triangles, and those are in the file called sierpinski.js, that's here. Um, I made I found existing Python code for a fractal called a Sierpinski curve on the web, and I just translated it from Python, pure real Python, into this JavaScript version of TurtleGrafx that I have. You can see this is a translation. It uses a function called draw Sierpinski, which I pulled out and made into its own function just because it's a fairly large piece of code. And we wanted to get that. It's used in a block, but we didn't want to put it in line in a block. Let's look at an example. Here is, I'm going to open up a Python, a window on a Python version of the block. And that will be here. I'll just open it from here. Of course, I'm having difficulty finding it, but that's okay. It's right here. Okay, I opened this up in an editing tool, a simple editor called Thonny. You might have used this for some of your Python work. You could do the same thing in Visual Studio Code or any other um, Python centric editor. There's nothing very special about it. This is the code, and when I run this code in Python, now this is a Python code, you'll see it draws the same multiple inset triangular pattern that you see in the purple pattern in the quilt. This one's not filled, it's just an outline. And you have the option in the version that I created to have the some of the triangles filled. And you can actually see that. That's why it shows up in purple on the canvas. So it turns out that many of these commands don't need to be changed at all. So just in overview, what I had to do to get this function, sierpinski.py, into a JavaScript function that I could use in the quilt was pretty simple. I got rid of import turtle because I'm going to make you pass a turtle in a reference to a turtle in anyway, so we don't need to import it from an external file. It's already in the file called pin.js, which is in the framework. The function draw Sierpinski is declared with a def for short for definition in Python. In JavaScript, you don't need that, so you can just give the name. The if statement is pretty much exactly the same. The for loop has to change because this is a Python for loop, and JavaScript for loops look a lot more like the C for loops that you may have seen before, with the three parts: the initial value, the test, and the subsequent action. Python has a compressed version, as you can see, for loops that just run through numbers. That's pretty handy, but we'll have to replace that. The links, the FD for forward, just an abbreviation. So that works unchanged. Left works unchanged. And here's the else. All of these, none of these need to be changed, if I recall correctly. And then at the bottom, window equals turtle screen. No, we already have a canvas in the JavaScript version. We can get rid of that. The T equals turtle. That we can get rid of because we have that already in the framework as a pin. And there's the function actually being invoked. Well, our function will be invoked when the block is drawn, so we don't need that. And we don't need window.exit on click because this is not coming up in a separate window. It's coming up in the JavaScript canvas. So actually, the version in JavaScript will look somewhat similar. Let's look at the JavaScript version and see what it looks like. It's got this a function, draw Sierpinski. So instead of DEF, draw Sierpinski, I've just got function. That's how you introduce the definition of a function in JavaScript. It's got the links and depth parameters that were present in the Python, but it also has a new parameter T, and that's going to be the pin, the turtle element in our framework that we can use to draw with, just as we drew in with the turtle in Python. Here's the for loop that had to change. It has to go into this form, which instead of the compressed Python form, but you may be familiar with this form from Java or from C or many other languages that use braces extensively. It's begin with 0, keep going while the count is less than 3. So it's 0, 1, 2, 3. That's 4 values. And every time you loop, increment the loop variable, right? Go forward a certain distance and go left 120 degrees. That's exactly what the Python code does. See if I could get the Python code up here at the same time. Sort of. So you're comparing this code to this code. In the else, that's where all the action happens. This is a fractal, so the code it generated is going to look kind of cryptic. That's because it makes extensive use of recursion, which none of your blocks are required at all to use recursion. It's just the easiest way to draw a number of different fractals. If you want to draw a spiral or some other shape, you won't need to do that at all. You will need to convert it, but you won't need a recursive function. And below the else, the code is basically the same between the Python and the uh, JavaScript implementations. And that's pretty much it because, as I said, we no longer need this stuff down here because it's built into our JavaScript Quilt framework. So I pulled this code out and when I converted it, and I stuck it in its own file just to be tidy, really, called Sierpinski.js. That weird name comes from it's named after a mathematician. I think it was a Russian mathematician who did a lot of work in fractals. You can play with the length and depth parameters if you want and get different results. If you make the depth very large, it will take forever to finish. Um, so now in so I need to make a block out of this, right? I have the code to draw one of these purple triangles you see. I need to make it into a block. That happens in Turtle Sample. First of all, it extends block, so it gets all the block functionality, the coordinates, the colors. And then in the render method, again, I had to kludge up the coordinates a bit to get this to work. That's what the fudge X and fudge Y. Got to be a better way to do this, but you can figure that out if you want. I had to shift them a little bit to make them line up. Um, Set the fill color. That's how I got the purple. It's all red and all blue and no green. That gives you purple. Um, Set the position. That's the part I had to fudge to get it to land in the right, each block to land in the right place. Console.log is just a debugging message so I can tell where I am. And draw Sierpinski calls the code we were just looking at right here. That's the definition of the function. This is the invocation. And notice the extra parameter. Notice the this.t. What is the this.t? This.t is comes in as a parameter, an argument named the turtle. And if we look at where this block is actually added to the quilt, that's in sketch.js, you'll see that it's actually being passed t there. The names keep changing, but the function is the same. It's passed t. T is a pin. And remember, a pin is just a class that collects together those Python turtle methods that I've converted to JavaScript. So it's like a tool that the block can use to draw uh, shapes using turtle graphics. So having done all that, everything from this point on is pretty much automatic in the sense that when you run the quilt, it will, the framework takes care of repeatedly drawing. We talked about that last time, going through the array of blocks that we've created and repeatedly drawing the appropriate block from that position. Now, I chose a fairly complicated but pretty example. You could obviously come up with a turtle graphics pattern that's considerably simpler to understand than the Sierpinski triangle, but that's up to you. You have the option now, in addition to the graphics that are produced directly by built-in P5JS methods like triangle or rectangle or circle or line. You can also build your own using Turtle Graphics and have blocks that consist of Turtle Graphic drawings. So what a quilt really is a collection of small drawings. Uh, and they're repeated. Actually, the repetition is part of the attraction of this. And you can come up with something like this, or I think you can probably come up with something much better than my attempts. So if you want to go that way, you've got the code in Python, you really like what you did in Python, produces an output that you like, then try converting that into a block, following Turtle Sample as a model, call it something different, um, and change the render method to be the converted uh, turtle graphics from your uh, Python example into JavaScript, and then everything should, cross your fingers, take care of itself. So that's the big idea of you don't have to use this technique. You can make all your quilt entirely consist of blocks that are borrowed or from others and or constructed by using the turtle graphic, built-in turtle graphics. But if you want to experiment, if you want to learn some additional, I think, interesting material, try drawing some things with turtle graphics in a block and then putting that block into your quilt. That's all I have. Thanks a lot, folks.